Hello all, welcome back. In this session, we are going to see K nearest neighbor algorithm in machine learning, and in addition to that, we are going to see what are the methods used to measure the distance between 2 points, the test point and the actual data point, and the tutorial problem related to KNN, and one quiz and two tutorial problems. Credits to NPTEL, Jignesh Bachar, and online resources. K nearest neighbor. KNN is a supervised, non-parametric, instance-based and lazy learning, where this non-parametric makes no assumptions about the distribution of data. That's why we are calling it as non-parametric. Why we are calling it as instance-based learning? The algorithm doesn't explicitly learn any parameter on its own. And what is this lazy learning? So whatever the data points you have in the dataset, it will compare the distance between the test data and the train data. So the KNN is not suitable for the data if it is noisy. So in distance measures, you have three methods. In this case, I have considered only three methods. One is Euclidean distance, Manhattan, and Minkowski. And consider this red point is a train data, and this blue point is a test data. For example, Euclidean distance means it's a straight line distance between 2 points, like the shortest path between 2 points. Like we can connect the 2 points with the help of rulers. But whereas this Manhattan distance is movement only in horizontal and vertical, like moving through a city streets, like that. So there is no diagonal path. You need to go by step path in Manhattan. But in Minkowski, it is something, it's like it can behave like Euclidean as well as Manhattan. So in other words, we can call it it's a flexible distance. It is a flexible distance. In short, we can call Euclidean distance as a straight line distance, Manhattan as a grid path, and this Minkowski as flexible distance. So KNN, consider in this case you have category A and category B. Category A are squares and category B are circles. And there is one test data X. I am going to introduce in this triangle X as a test data. Now you need to classify where this test data comes, whether this triangle belongs to category A square or category B circle. This algorithm will calculate the distance between X and all the instances of train data. So you have n number of instances, right? It will consider it will calculate the distances, and it will arrange the distances in increasing order or ascending order. If in KNN, if k value is 3, then it will select the 3 nearest instances based on the similarity measure. As per your ascending order, if k is 3, it will take only the first 3 rows. Using k neighbors to determine the class of X using majority voting method. In this case, the voting method is preferred. And this is the procedure to measure KNN implementation method. And how you are going to choose the value of k? In KNN algorithm, k value is the hyperparameter tuning. So normally it depends upon individual cases. So best way is to choose k value ranges from 1 to n. That is, n means number of training data points, that is number of rows. In many cases, they will take k as square root of n value as k. And you need to be very careful that always k value should be a odd value. So in order to avoid the tie between the predicted class, so we can always choose odd values for k. So if k is small, what will happen? It means that noise will have a higher influence on the result. That is, the probability of overfitting is very, very high. But if you choose k value as large, then the decision may be skewed. It will increase confidence in prediction, and computationally it is very, very expensive. And in short, If I need to conclude KNN feature, it is non-parametric, simple, and it comes under supervised learning algorithm, and it is used for classification as well as regression algorithm, and based on feature similarity it works, and it is a lazy algorithm. And the quiz for you people is, in which of the following images, you have three images A, B, C, KNN will fail, right? You have two data points, red and green colors. What will happen if you build a KNN model with K which is equal to 1? Use KNN algorithm to classify the test data using K which is equal to 3. Consider the two features, feature 1 and feature 2. You have the test data. I am going to introduce the test data as -1 and +1. And we have the class information for all the data points. And for test data alone it is not available. In this case we are going to use only the equivalent distance method. Look here, the KNN algorithm K which is equal to 3, you have 8 data points, and the ninth test data is the -1 and 1. Now I am going to use the equivalent method to find the distance between test data and the first point -2 and 1. -2 and -1. Now the test data point is -1 minus of -2, it is +2 the whole square, plus test data second point is 1 minus of -1, that is plus the whole square. So you will get square root of 1 plus 4 which is equal to square root of 5, that is 2.23 approximately. And now the distance between test data and the data point x2 is square root of -1 minus of -2, that is +2 the whole square, plus 1 minus of second data point -1 the whole square. So it is becomes 0. So it is -2 plus 2 -1 plus 2, it is square root of 1 which is equal to 1. Same way the test distance, the distance equivalent distance between test data point -1 and 1 with respect to train data -2 and 2 is square root of -1 plus 2 the whole square plus 1 minus 2 the whole square, which is equal to square root of 2 which is equal to 1.41. Same way we need to calculate for remaining 8 data points, and we need to write all those data points in ascending order as well as with respect to the points and what the class belongs to. We need to make it in ascending order as distance wise, like 1, 1.41, 2, 2, 2.23 and 3 and 4 etc. Now in this case the value of K is 3, so we are going to consider only the first 3 rows, and by voting mechanism, and we are going to check how many classes are wins. In this case C2 wins. Why C2 wins? C2, there are two C2 values are class and one C1 class. So C2 is greater than C1. So let me consider by using KNN the test point belongs to C2. Fine, like this. In 2D view, if you see in geometric point of view, the test point is -1 over here and +1 over here. We have 3 classes. These circles are C1 and these cross points are nothing but C2 class, and this 3 class belongs to C3, and this test point -1 and 1 belongs to C2 class. Fine. You can see one more example, and here we have considered 12 data points. By considering humidity, temperature and rain, the input features are humidity and temperature, and output feature is rain. Will it rain if humidity is equal to 84 and temperature equal to 34? We need to say whether it will rain for this particular condition. Fine. In this case the hyperparameter tuning for K value as 5. Now we need to do the calculate the equivalent distance. In this case we are going to calculate the equivalent distance between the test point and the train point, actual data point. So, and we are going to write all those distance in ascending order, equivalent distance in ascending order, and we are going to have the particular class label. And in this case, the value of k, which is equal to 5, by considering the 5 rows, you can see when humidity equal to 84 and temperature equal to 34, it will rain, since you have 4 ones and 0 and 1 zeros. So 4 is greater than 1. So we can going to say it will rain for this particular condition. Task 1 for you people is, when x1 equal to 3 and x2 equal to 7, what will be the classification when hyperparameter value of k is 1 and 3. Kindly type your answer in comment box below. And the second task for you people is KNN example using iris flower. In iris you have 3 categories: iris versicolor, iris setosa and virginica. Fine, and consider this data set. Kindly pause the video at this particular point and calculate the sepal length of 5.2 and sepal width of 3.1, what species it belongs to. Kindly give your answer in the comment box below for quiz task 1 and task 2. We'll meet you all again in another video. Thank you.